This is a video from section 3.2. In this section, we're going to highlight two rules for taking derivatives. The first one is called the product rule. The product rule says the following. If f and g are both differentiable, then the derivative of f of x times g of x with respect to x is equal to f of x times the derivative of g of x with respect to x plus g of x times the derivative of f of x with respect to x. So that's called the product rule. The quotient rule says the following. If f and g are both differentiable, then the derivative of f of x divided by g of x with respect to x is equal to g of x times the derivative of f of x with respect to x minus f of x times the derivative of g of x with respect to x. And I'm going to divide that whole entire thing by g of x quantity squared. With that in mind, we're going to look at some examples. Now, the directions say to differentiate. And the first one I want to look at is number 5. Suppose I'm given y equals x to the third times e to the x. And I want to take the derivative. Now, in this example, notice how f of x is equal to x cubed and g of x is equal to e to the x, right? And so this is a product of two functions, and that allows us to use the product rule. So I'm going to find y prime. So in other words, I'm going to find the derivative of y with respect to x. So I'm going to write down the first function, and I'm going to take the derivative of the second function with respect to x. So in other words, I'm going to write down x cubed, and I'm going to take the derivative of e to the x with respect to x, plus, then I'm going to write down the second function, which is e to the x, and I'm going to take the derivative of the first function with respect to x. So in other words, I'm going to write down e to the x and take the derivative of x cubed with respect to x and multiply those together. And so therefore y prime is x cubed times the derivative of e to the x with respect to x is e to the x. So I write x cubed times e to the x plus e to the x times the derivative of x cubed with respect to x is equal to 3x squared. And we're going to simplify this a little bit. So I'm going to factor out an e to the x, and I'm also going to factor out an x squared. So that's the GCF. Now, when I do that, notice how I have 1x left over from the first term, and then I'm going to add 3. That's what's left over from the second term. And so the derivative ends up being x squared e to the x times the quantity x plus 3. And that right there is how you do problem number 5. If we take a look at problem number 6, we have the following. Suppose y equals e to the x plus 2 times 2e to the x minus 1. And so this is a product of two functions. And so in this example, f of x is e to the x plus 2, and g of x is equal to 2e to the x minus 1. And I want to find y prime. So I'm going to write down the first function, which is e to the x plus 2, and I'm going to multiply that by the derivative of the second function, which is 2e to the x minus 1. And then I'm going to write down the second function, which is 2e to the x minus 1. and I'm going to multiply that by the derivative of the first function, which is e to the x plus 2. So when I take this a little further, I'm going to write e to the x plus 2. And then the derivative of 2e to the x minus 1 with respect to x is 2e to the x. And then I'm going to add 2e to the x minus 1 times the derivative of e to the x plus 2 with respect to x, which is just e to the x. And if we simplify this a bit, 2e to the x times e to the x is 2e to the 2x. 2e to the x times 2 is 4e to the x. So far I have 2e to the 2x plus 4e to the x. And then I'm going to add 2e to the 2x minus e to the x. And if I combine like terms, I have the following. Y prime is 4e to the 2x plus 3e to the x. And that's how you do problem number 6. If we take a look at the next one, so we're going to do problem number 8. In problem 8, we have the following. G of x is equal to x plus 2 squared of x times e to the x. Now, could I distribute the e to the x inside to each term? Yes, I can. The problem, though, is you're going to apply the product rule to 2 different terms. And I don't really want to do that. I want to be able to apply the product rule one time. And in this example, I'm going to say f of x is equal to x plus 2 squared of x. And since g of x is already taken, if you guys don't mind, I'm going to say the other function we'll call h of x is equal to e to the x. And so suppose I want to take the derivative. Now, I'm going to write down the first function, which is x plus 2 squared of x. And I'm going to multiply that by the derivative of the second function, which is e to the x. Plus, I'm going to write down the second function, which is e to the x. And I'm going to multiply that by the derivative of the first function, which is x plus 2 square root of x. Now, this is x plus 2 square root of x times e to the x plus e to the x. Now, before we take the derivative of x plus 2 root x, I'm going to rewrite this as the derivative of x plus 2x to the 1/2. So it's going to be a little bit easier to take the derivative of that. Now, so I'm going to distribute the e to the x inside. And so I get x e to the x plus 2 square root of x times e to the x plus e to the x times. Now, the derivative of x is 1. Now, I'm going to apply the power rule on 2x to the 1/2. And remember, 2 is constant. And so what I'm really doing is I'm just taking the derivative of x to the 1/2, and 2 is going along for the ride. So in other words, I'm going to write 2 times 1/2 x to the negative 1/2, just like this. So this is x e to the x plus 2 root x e to the x plus. Now I'm going to distribute the e to the x in, and then also remember that half of 2 is 1, right? So I get e to the x plus x to the negative 1/2 e to the x, like this. And so therefore, g prime of x is equal to the following. I get x e to the x plus 2 square root of x e to the x plus e to the x plus e to the x divided by x to the 1/2. And what I'm going to do is I'm going to get a common denominator, and the common denominator is x to the 1/2. So I'm going to rewrite this as a single fraction. And I want to again stress, it's very important to be able to do that for when you get to chapter 4. Now, in the denominator is x to the 1/2, right? And so I'm going to multiply the first 3 terms up here by x to the 1/2. So x times x to the 1/2 is x to the 3/2 e to the x, right? Plus 2x e to the x plus e to the x, here, we'll make room here, plus x to the 1/2 times e to the x plus e to the x. I don't have to multiply the last term by x to the 1/2 because there's already an x to the 1/2 in the denominator. And that's how you do problem number 8. Let's take a look at problem 10. Suppose y equals e to the x divided by 1 minus e to the x. Okay. Now, this is a quotient, and here we have f of x equals e to the x, and g of x is 1 minus e to the x. So I want to take the derivative. So I'm going to write the bottom function, which is 1 minus e to the x, and then I'm going to multiply by the derivative of the top function with respect to x, like this. And then when you have a quotient minus, then I'm going to write down the top function, and then I'm going to multiply by the derivative of the bottom function, which is 1 minus e to the x. And remember, you're differentiating with respect to x. And then I'm going to divide by 1 minus e to the x to the second. So y prime is 1 minus e to the x. The derivative of e to the x with respect to x is e to the x. I'm going to subtract e to the x. And then I'm going to take the derivative of 1 minus e to the x with respect to x, which is 0 minus e to the x. And then I'm dividing by 1 minus e to the x squared. So therefore, y prime is, I'm going to take e to the x minus e to the 2x. So notice how I just distribute the e to the x inside. So I get e to the x minus e to the 2x. And then negative e to the x times negative e to the x is positive e to the 2x divided by 1 minus e to the x to the second, and we're done. So y prime is e to the x divided by 1 minus e to the x squared. And this one's a nice application of the quotient rule. So this one was number 10. If we take a look at number 11, suppose y equals 3 minus 2t divided by 5t plus 1. In this example, f of t is 3 minus 2t, and g of t is 5t plus 1. So I want to take the derivative. Now, contextually, it's with respect to t, not x this time. And so I'm going to write down the first function, right? The bottom one, which is 5t plus 1. And I'm differentiating with respect to t, the top function, which is 3 minus 2t. Then I'm going to subtract 3 minus 2t, the top function, times the derivative of the bottom function. And then I'm going to divide by this whole entire thing by the bottom function squared. So I get 5t plus 1. The derivative of 3 minus 2t is negative 2. And then I subtract 3 minus 2t times the derivative of 5t plus 1 with respect to t, which is equal to 5. And then I'm going to divide by 5t plus 1 to the second. Okay? And what I'm going to do is I'm going to distribute the negative 2 inside, like so. So, therefore, y prime is. Now, for the denominator, we're going to get 5t plus 1 to the second. For the numerator, we're going to get the following. We're going to get negative 10t minus 2 minus 15 minus 10t. And then we're dividing by 5t plus 1 squared, that quantity. And so, if you notice, I'm going to get the following. Negative 10t minus 2 plus. Now, I'm going to distribute the negative in, and I'm going to get negative 15 plus 10t. So when you distribute the negative inside those parentheses, you change the sign of the terms within those parentheses. And then again, I divide by 5t plus 1 to the second. And I want you to notice how these 10t terms disappear. And essentially we're done. So what this says is y prime is negative 2 plus negative 15 is negative 17 divided by 5t plus 1 to the second. And that right there is how you do problem number 11. And let's do one more for this video here. So let's take a look at problem 16. Suppose y is square root of x divided by square root of x plus 1. And if you don't mind, I'm going to write this as x to the 1/2 divided by x to the 1/2 plus 1. So f of x is x to the 1/2, and g of x is x to the 1/2 plus 1. So I want y prime. So I'm going to write down the bottom function, and I'm going to take the derivative of the top function. And if you don't mind, I'm going to directly take the derivative. So it's x to the 1/2 plus 1 times 1/2 x to the negative 1/2. So that's the derivative of the numerator. And then I'm going to write down x to the 1/2. That's the top function. And I'm going to take the derivative of the denominator, which is 1/2 x to the negative 1/2. And remember, the derivative of any constant is 0, right? And then I'm going to divide by x to the 1/2 plus 1 to the second. So I'm going to distribute. So I get 1/2 x. 1/2 minus 1/2 is 0, so it's 1/2 x to the 0 plus 1/2 x to the negative 1/2, like so. And then I'm going to subtract 1/2 x to the 0. I'm going to divide by x to the 1/2 plus 1 to the second. But I want you to notice something. The first term and the third term are like terms. They cancel because 1/2 x to the 0 minus 1/2 x to the 0 is 0. And so what we end up getting is y prime is 1/2 x to the 1/2 divided by x to the 1/2 plus 1 to the second. But remember that x to the 1/2 is square root of x, right? And so therefore, I hope you guys don't mind blue, y prime is x to the 1/2 divided by 2 times x to the 1/2 plus 1 to the second. And then again, I said square root of x, so let's also emphasize it can be written this way as well. So I could write square root of x divided by 2 times square root of x plus 1 to the second. And that'll do it for this video for section 3.2. And we talked about the product rule and the quotient rule. And on top of that, we worked problems 5, 6, 8, 10, 11, and 16. Okay, thank you.